Hello, everybody. Welcome to another episode of X City. The last time we talked a little bit about how do you select the right type of paint for your building project in Liberia, especially considering Liberia is a very humid and wet country. So the way you paint homes in residential buildings or in general any type of buildings in other climates are not necessarily the right way you select or the right type of paints you select for your homes in a country such as Liberia, which is one of the top 12 most humid countries and one of the wettest countries in the world. So this was an educational thing. It was a little bit veering off of the theme of the channel, but based upon popular requests about materials like this, which are educational, I decided to actually make another one. And this time around, we are going to be talking about how do you design your septic tank. So we know in Liberia, a lot of times, in most cases, when you build, whether it's commercial buildings or residential homes, you have to build your own septic tank that stores your sewage from your home. So I realized that a lot of times this is designed the wrong way. I didn't do a survey, so let me just step back a little bit. I didn't do a survey, but I asked several people who were doing construction work in Liberia, and I actually stumbled upon this ongoing errors in the construction industry in Liberia because I had a septic tank to build for my mini office building that I'm constructing in Johnsonville. Today, I wanted us to dive into how do you design a septic tank. This is for people who are having an off-grid sewage pipeline system. And this is true for most places in Liberia. And I learned from my experience in Liberia that some engineers wrongly design and build septic tanks, and this actually has a severe impact on our water system, the groundwater system. So it has impact on our environment because the design actually leads to a lot of pollution. So I wanted to make this quick video and just talk a little bit about that. The one thing you want to do when you design a septic tank is that you don't want to build a single compartment vault. You want to build a multi-compartment vault. And also the next thing is that you also want to make sure that the flow of your septic tank is actually cemented with concrete, right? You don't want to leave it exposed to the earth and just allow your sewage matter to seep into the ground. And that is the primary reason why I'm in fact making this talk, because I did realize that this is how some engineers in Liberia or some builders, I don't want to say engineers in general, because some of these people are actually just builders who learn through apprenticeship, and they are not necessarily classified as engineers. And sometimes there's a little bit of a questionable credentialing system that gives them the right to call themselves engineers, but they do call themselves engineers sometimes. However, the point of this discussion is that do not leave the floor of your septic tank exposed to the earth, as most people do in Liberia. So what do you do? So you want to make sure you pour concrete floor. And then you want to make sure that your septic tank has at least 2 compartments. The one I built for my mini office space in Johnsonville actually has 3 compartments. But let's talk about why you need compartments and why you need concrete flow. You need a concrete flow to prevent groundwater pollution by letting sewage sit directly into the earth without any concrete bottom that protects the feces and other waste from just contacting the earth and groundwater directly. It leads to pollution. It leads to the contamination of groundwater. So you want to prevent that. You never want to do that and leave it exposed. Even if you don't have well in the vicinity of your septic tank, it is a bad practice, and we need to stop doing that. It has a long-term ramification on our environment. So stop doing that in Liberia. And if you are about to build a septic tank, please advise your builders to not leave the bottom of the septic tank exposed to the earth. And so why do people tend to do that? I think the reason is because septic tank do receive a lot of fluid, a lot of water, right? In addition to solid waste. And when the fluid builds up into the septic tank and doesn't seep through the ground, it basically fills up quickly. And because people want to prevent that, the easiest solution is for them to just let the thing just, drain into the earth. But that is the bad thing. It may be the easiest solution, but it is a lazy solution and it is a harmful solution. So let's stop doing that. Now, after you put the concrete, now you are faced with the challenge of now you have a septic tank that will easily fill. And that is why we need a second compartment, or at least one more compartment. So when you build your septic tank, build it large enough, and the exact dimensions will depend on the usage, the load, and things like that. The load being like how many toilets, how many humans are using it, what is the use case here. So you have to decide. I talk to someone who can advise you on that, or talk to us, we will advise you on that. But make sure to have two compartments, and the first compartment basically is what is going to host all of the first things that leave your building, right? All of that mixture of liquid and solid waste is going to go into the first compartment. So it should be large enough. That should be almost the typical size of what you call your septic tank normally. The one vault or one whole septic tank you've been building, that first compartment should be about the same size for your septic tank. And then you need to dig a second compartment. And it's a little bit costly. And this is where people start cutting corners. But do not cut corners, because you are contaminating the groundwater if you just do a single vault and then leave the floor of your septic tank exposed like that to the earth. So you want a second compartment. And the second compartment, now you're going to create a wall between the two compartments, but you're going to bore a hole in that wall, at least one hole. Actually, you should do two holes, as I did in my case. One of the holes should be about 4 feet from the surface of the ground towards the bottom of your septic tank, and the other one should be about 2 feet below that. Why do you need those two holes? The reason is as follows. When your sewage matter leaves your building and goes into the septic tank, the first vault, it has a mixture of waste matter. One is the solid matter, which sinks to the bottom because it has the highest density of all the three categories of things that are coming into the septic tank. So the solid waste has the highest density, so it sinks to the bottom. The second one is the effluent matter. By the way, the solid waste that sinks to the bottom is called a sludge. Now, the liquid matter that is in the middle layer is called the effluent. So that is where most of the water that is in that mixture that comes out of the building basically resides. It's in the middle layer, right? It's the water. It has lower density than solid matter, so it's floating above. So it's sitting above the solid waste. And that is the effluent. The top layer of things, usually those ones contains like those oil and grease and things like that are floating over water, right? Because they have lower density, so they'll be floating over water, right? And any things of such matter that are floating, they are usually like those type of oily substances. And that is called the scum layer of the waste matter that is sitting in that first vault. Now, those two holes that I just talked about, basically creating between the first vault and the second vault, or the first compartment and the second compartment, those things are placed at those depths. Remember, I said 4 feet from the top surface, and then another 1 to 2 feet below the first hole. Those are the places where you make these holes. Those ones are usually there to capture your effluent matter and basically transmit them to the second vault. So those things usually do that. Now, why do you want two holes? The reason is as follows. When a solid waste starts climbing up, and then it can reach the top and then hit the first hole that you dug, right? So that one will be like about 6 feet from the top surface of the ground. So it can close that one down, and then you will have only one pipe that is working that to carry the effluent matter into the second vault. That is why you need two holes, right? So by the time the second hole gets clogged, then your vault actually is time to remove some of that solid matter, right? That's when you bring your waste trucks, and then they suck out the solid waste from your vault. But at least you need those two holes so that when one is shut down, the second one is still functioning to remove the effluent matter until the solid waste shuts that down. And that's when you don't want that to happen. Actually, you want to suck it out, but in the eventuality of that happening, you have a backup system. That's why you need those two. So what happens when the effluent matter goes into the second compartment? Well, again, that effluent matter, although it has been taking the liquid from that middle layer, right, and carrying it up, but that liquid also contains some solid matter. And as we say, in instances where the solid matter rises till it reaches the height of the lower conduit between the two vaults, it starts basically carrying some, slowly carrying some solid waste into there. But even when it is functioning normally, liquid that is going into the second vault may have some solid matter, right, that is floating around in the liquid, right, in that liquid mixture, right? So some of that is gained over time. Once they are sitting in that second vault, after some time they tend to sink to the surface, to the bottom of that second vault. And again, so you have small amount of sludge in the second vault, but usually it's like less than a quarter or around a quarter of what you have in the first vault. But then that effluent matter now that is in the second vault, remember it has been distilled by allowing the pipe to carry it from the first vault to the second vault. A lot of the one, by the time it reaches to the level of any of those pipes to be transmitted, it has already basically allowed most of the solid matter to sink. So that effluent matter that is going from first vault to the second vault is actually much more cleaner than the one that came directly from your building, because it has already allowed the solid waste, most of the solid waste, to settle. So that effluent matter that is in your second vault is what basically you want to use for manure. And that is the one you actually want to allow to basically seep into the top surface layer of your soil. And that provides a lot of manure for things that you may want to grow. That is where you want to grow your vegetables, and they will be the freshest vegetables you can have. And that is where sometimes you want to grow your grass. Now, for people in the West, like in the United States, if you see like cluster of homes where the engineering or the construction company actually design a waste collection system that basically accumulates waste from different buildings into one centralized septic tank before the waste can again go further down into the discharge pipes to take it away from the community. That centralized septic tank for that community has what we call a leach field. So in this case of our two compartment septic tank, what that translates to is that from the second compartment, we need to build, again, dig a hole that is around, again, from the compartment up to the open earth now. So we're going to dig a channel in the ground that hits the wall of that second compartment, but the depth of that hole should be around 4 feet. And then we should dig a 4-inch pipe hole. By the way, all of the pipes we are digging to connect two compartments, there should be around 4-inch holes, diameter holes, and you can fit in like the 4-inch PVC pipes in it. Again, you need to design the pipes in such a way that they will allow free flow of fluid between the two compartments, and we can talk about that later. There's a detail of how you actually design it to allow basically the pressure in the pipe to be in such a way that the fluid can flow smoothly. But that's a detail like you should talk to your engineer about, or we can basically sketch the diagram how it looks like. But so you're gonna dig that hole 4 feet. So you dig a channel like a guado, you dig it on that side, on that face of that compartment into the earth. It should be about 10 feet long, stretching into your yard, right? Not in the street or in someone else's yard. Because above that 10 feet pipe, actually, so you're gonna put a PVC pipe and make a hole in the wall of that second compartment, and then you're gonna perforate the walls of that pipe, like around the ribs, right? So if you think about it, if you look at the cross section of the pipe, if it is like a clock, so you have 12 o'clock, you have 6 o'clock, so you want to dig those holes around, say, maybe like the 5 o'clock and around like the 7 o'clock, so they are not directly underneath the pipe is laying on the ground, remember? So it's going to be like on the side, on the rib cages, like not a rib cage, but on the rib of that pipe, right, along it. Like you can build, like you can put some pairs of holes along there, so that the purpose of these holes is that you basically just use a drill really to make these holes. The purpose of these holes is that as the effluent matter that is in the second compartment, once it rises up to that level, right, when it reaches that level of that pipe and of that hole, that effluent matter, that liquid will start to flow in that pipe. But you don't want that liquid to flow all the way to the end of the pipe, to 10 feet. Actually, you want it to start basically just draining out of the pipe as it rolls down. And the reason why you're not digging the hole under, because then all of the liquid will just be basically draining out in one spot or very close to the septic tank, but you want some of that liquid to reach all the way to the end. So if you think about the pipe being like this shape, this half oval shape, right? We're not talking about the top part, but you want the hose like around the rib here, so that liquid can still flow at the bottom, but when liquid goes up higher, it starts getting out here, and as it goes, basically it drains out the pipe. So some liquid goes as far as possible, but they are draining out slowly, and you don't make big holes. You just use like a drill bit, like normal size drill bit, right, to just make little holes in there. So that's the case. And that area above that 10-foot pipe that you're going to lay, that connects and carry out your effluent matter out into the ground, into the topsoil area, is what we call the drain field, or sometimes people call it the leach field. So that is where the greenest grass in the US now. I was talking about this cluster of homes. When you see some communities where you see there's a little community park where the grass is really green, beneath there is where you have your leach field. So that green grass, the most beautiful and greenest of grass in that community area that people love to go and play and picnic and things, all of that greenness, the thing that is causing it is your sewage liquid. But it is good for the soil, and that is the menu actually for the soil, for the plants, for the grass and things like that. And in Liberia, if you think about it, if you're growing grass or your vegetables or your little garden, that is the best place to make your garden. So you want to do that. So that is how you want to build your septic tank. If you want, you can make like what I did. I did 3 compartments, in fact. Now you may say, why weren't you overdoing it? No, actually I wasn't overdoing it. Actually, it is necessary to do that in many cases, because maybe you want to filter out a lot of the sludge that could potentially still remain in that effluent matter as you discharge it into the field, into your leach field, right? So building 3 compartments, every time the effluent moves from one compartment to the other, it gets distilled. The distillation basically is the solid waste is falling to the bottom in the previous compartment and goes into the next compartment. It's much, much clearer. So by the time it gets to the 3rd compartment, you are getting like really a clear liquid that is really good for your soil. I mean, it's not good for consumption, so don't get me wrong. Don't build a well anywhere near that. Leave a good amount of distance, and that also depends on the soil composition, the soil type, to determine like how far away from your septic tank you should dig a well. I'm not going to get into that, but that is the idea of just designing your septic tank. What else could I think about? Yeah, I think that is it. I will stop there. But I did design a septic tank in Johnsonville like that, and the reason why I got into it is because I asked people to dig the septic tank, and they were digging it. And I asked the guy, how are you going to design the septic tank? And he explained to me that it was going to be one hole and just build the walls, the solid concrete walls around it and cover it up. And I said, what about the bottom? What do you do when you dig the hole? What do you do with the floor? And he said, no, we just leave it like that. I was like, you just leave the sewage to sit, the raw sewage to sit on the ground like that. He said, yeah, that's the way the water will drain out. If not, this thing will get filled with water very quickly. I said, but yeah, I get the concern about the vault getting filled up with water, but I don't think this is sound engineering. And as naive as I was, I didn't really know anything about how a septic tank is designed, but I knew right away. And thankfully, I had asked him to tell me like, what is he going to build for me? And when he explained to me, it didn't sit well with me, and I told him no. So when I researched it, I actually helped him implement this septic tank. Thankfully, I had gone to Liberia with all of my drilling machines and my equipment and things. So I helped design the pipe. I actually physically drilled the holes into the walls that are separating the compartments, and actually installed the pipes. Perforated the pipes for the leach field and basically installed them myself. So I hope this video helps, and I think you can look at this attached diagram. This is a 2-compartment system, but as I said, having a 3rd compartment is not a bad idea, but at least do a 2-compartment system as is shown in this diagram. You will be helping save our environment in Liberia. You will be helping prevent groundwater pollution and just soil pollution in Liberia. Thank you, and you have a wonderful day.